Hello everyone, in this video I'm going to solve 25 problems and this is exam 1 review for MAC 2311. The first question is find the average rate of change of the function over the given intervals. So we have given a function f of x equal 10x cubed plus 10 and we have given intervals for the part A from 4 to 6 and for the part B from -5 to +5. For both parts, we're going to use the same formula. So, so let's start. One. So average rate can be found over average rate of change of the function can be found over an interval from a to b for the function f of x using this formula f of b minus f of a over b minus a. So the function for this problem we have given is 10 x cubed plus 10, and for the part A there are two parts. For the part A the interval is given 4 to 6, so that means this is the value of A and this is the value of B. So we just have to find out f of B, which is f of 6, and you can find this value by substituting this x equals 6 in the given function, and that is 10 times 6 cubed plus 10, which is 2170. And we can do the same thing for f of 4, which is 10 times 4 cubed plus 10, and that is 650. So now we have a formula, this formula, so we just have to use that formula for finding the average rate of change. And if you plug that value, 2170 for f of b, 650 for f of a, and 6 for b and 4 for a, you will get 2170 minus 650, that is what is that? I can use calculator for that. 2170 minus 650 and divide by 2, so it's a 1520 divided by 2. 1520 divided by 2, that is 760. So the average rate of change for this function on interval 4 to 6 is 760. So the first answer is 760. By doing the same thing for part B, we're going to find 250. So just find out for the part B, find out this is -5 to +5, find out f of 5, which is 10 times 5 cubed plus 10, which is 1260, and f of -5 is 10 times -5 cubed plus 10, which is -1240. And by using the same formula, this formula again, 1260 minus f of a, which is -1240, divided by b, which is 5 minus a, which is -5. So that is actually 1260 plus 1240, which is 2500, divided by 10, which is 250. Okay, so for this part B, For the part B, the average rate of change is 250. Okay, so that's problem 1. And now let's go to problem 2. Find an equation for the line tangent to y equal -2, -3x squared at 4, comma, -50. So at this point, we don't know how to find the slope of a curve uh, at some points, so we're going to use secant line to find the slope. If you remember the equation of tangent line, equation of the tangent line passing through point, let's say x1 y1, passing through point x1 y1 is y minus y1 equal m times x minus x1. So this is the equation of tangent line. We can use this equation to find out the tangent line. For this equation, you can see this m is slope of the tangent line, and x1 and y1, that's the coordinates of a point where we're trying to draw the tangent line. So let's try to understand the problem here. So let's say you have a curve, something like this, and we want to find out the equation of tangent line at 4, -50. We need to use slope of that line for finding the equation, but we don't know how to find the slope. So what we can do is we can just take another point which is very close to this point. Let's say this is point P, and there is another point Q, and we know that this curve is y equal, that's given here, y equal -2, -3x squared. So the curve is -2, -3x squared. So let's take another point on this curve which is very close to P. Let's take another point Q which is very close to P, and let's say this is 4, plus h. We don't know what is h. H could be negative value, but this h means this is a very small difference between point x coordinate of the point P and x coordinate of the point Q. If the x coordinate is 4 plus h, then now the y coordinate can be found by using this equation of this curve, which is y equal -2, -3x squared. So by using that fact, I can say this is -2, -3, 4 plus h squared. You can see here for x, I'm just replacing x by 4 plus h. So by doing that, what happens is now I'll be able to draw a line between these two points P and Q. You see this line? Okay, so now because I have these 2 points, I can find out the slope of the line passing through these 2 points P and Q. So I'm going to do that here. So here, slope of PQ, because you know the 2 points, the slope is the difference between the y coordinate over difference between the x coordinate. So you can see that the y coordinate for the point P is -50 minus the y coordinate for the point Q is -2, -3 times 4 plus h squared. Let me use the bracket here, over the difference between the x coordinate, which is 4 minus 4 plus h. So if you know the 2 points on a line, then you can always find the slope of that line by using y2 minus y1. Let's say you have a line passing through these 2 points x1 y1 and x2 y2, then you can find the slope of this line. Slope of this line can be found by using this formula, and that's the formula used to find the slope of PQ here. Now if you simplify this expression here, I'm going to focus here. It would be negative 50 minus, and because there is a bracket sign, I'm going to distribute this negative sign here. It would be positive 2, positive 3, and 4 plus h squared can be written as 4 plus h times 4 plus s. That will be actually 16 plus 8h plus h squared. On the bottom part, it would be 4 minus h. So we can cancel this 4 and this 4. And now on the top part, you just have to distribute this 3. By doing that, you will get negative 50 plus 2 plus 48 plus 24h plus 3h squared over negative h. So you can see that 48 plus 2 is 50 and there is a negative 50, so they will just cancel out. And now, on the top part, you can see that you can factor out h and 3. So it will be 20, if you factor out 3h, it will be 8 plus h over negative h. So you can write that negative here. So either you write negative on the denominator or numerator, that's the same thing. Now if I cancel this h, the slope would be negative 3 times 8 plus h. The good thing about the slope of the secant line for this curve is, focus on this curve. Our goal is to find out the slope of the tangent line at point P, and we don't have 2 points on that tangent line, so we started with the secant line by checking another point Q nearby P, and we found the slope of that line PQ. The only thing we have to do now is, if we make that h very close to 0, that means if this h is very small, then this Q point will be very close to P point, and this secant line becomes the tangent line at point P. So what we can do is here, when so you can see here, when h approach to 0, then this secant line PQ becomes the tangent line. The secant line PQ becomes the tangent line at P. So the slope of, if you want to find out the slope of the tangent line at P, then you just have to use this slope of the secant line, negative 3 times 8 plus h, and just put h equals 0. So when h approaches to 0, this thing, slope of the PQ line, slope of PQ is equal to negative 3 times 8 plus 0 becomes negative 24. Remember, we're trying to use that secant line to find out the slope of the tangent line. And now this negative 24 is the slope of the tangent line. Now we can use this, negative 24 for the slope of the tangent line at P. Okay, so now we can use this formula. Y minus y1 means it's the y coordinate of that point P, which is negative 50, equal the slope we found is negative 24. X minus x1 is 4. So now we just have to simplify this. Y plus 50 equal negative 24x plus 96. So if you want to simplify more, you can just subtract 50 from both sides, and it will be y equal negative 24x positive 96 minus 40 is 46. So this is the equation of the tangent line at point P. The equation of tangent line is negative 24x plus 46. So we're going to write down that value here. Negative 24x plus 46. That's the equation of tangent line at point 4, negative 5. Okay, and here is the complete work for this problem too. Good. Okay, so now let's go to problem 3. That is problem 2. Problem 2. Okay, let's go to problem 3. Okay, so there are different parts for this problem, and the problem is the figure given below shows the time to distance graph. So you can see that on the x-axis there is a time in second, and on the y-axis that's the distance uh, of an object which is falling from the top. So this is the distance for the time. Okay, the figure given below shows the time to distance graph for an object accelerating from a standhill. So when you can see that when time is 20 seconds, uh, the object is at P, which is the distance is 2600 meter. When time is another time, you can see 18 seconds, the object is at Q4, which is, you can see that you can approximate the value. It's difficult to find the exact value, but it's somewhere like 2200 meter, maybe it's in between 2000 to 2400. So similarly you can find all the points q1, q2, q3, q4 and p by looking at the graph. To answer the question, we have to know all this information. So now the first thing is the first part A. Okay, estimate the slopes of secant PQ1. So you can see the P and Q1. So the way we found the slope of the secant line in problem 2, we are going to use the same thing. For the PQ1, you have to use the coordinate of P, which is 2600. Q1 is approximately, it's you can see here it's at 10, comma, it's more than 800, so maybe I will take it as a 900. So I'm just taking the approximate value, it's not exact. So now the slope of the secant line PQ1, you can see, you can find it by using the formula y2 minus y1 over x2 minus x1. So if I use that formula, the slope would be 2600 minus 900 divided by 20 minus 10, which is, you can see if you subtract 900 from 2600, that would be 1700 and divide by 10. So if you do that, it will give you 170. So the slope of PQ1, and these are the options we have given, 3 options: 73, 267, 170. Even your answer, because we are just approximating this value of Q1, this coordinate for the y coordinate for the Q1, even your answer is not exact. You try to choose the the very close answer. But in this case, we got lucky that we are getting the exact value. So for the first one, the answer is 170. That means the slope of PQ1 is 170. by doing the very same thing, we can find the slope of Q2, and you just have to find the the coordinate for the Q2, which is it looks like it's a 14 for the x coordinate, and then y coordinate is maybe it's very close to, you can see that it's a 1500 maybe. So by doing the very same thing, the slope for the PQ2 is 2600 minus 1500 divided by 20 minus 14. So that is, if you subtract the 1500 from 2600, that will be 1100 divided by 6. And if you divide the 1100 by 6, it will be, let me use my calculator, 1100 divided by 6 is 183.333. 183.333. But the options we have given here, we don't have 183.333. So we choose, which is the best, which is very close to this value. Because if you remember, when I try to find this coordinate for Q to the Y coordinate, I just approximate the value and I choose 1500. I don't have any other way to find the exact number. That's why it's in between 1200 to 1600 and very close to 1600. So I thought it's a 1500, and that's how I got 183.33. And by looking at this option, the only option which is very close to 183 is 183. Okay, so this is my answer for the second one. And by doing the very same thing for the third one, which is you can find the coordinate. Uh, let's say this is you can see the x coordinate is 15, and then 16, and y coordinate is very close to 2000, so maybe 1900. So use this value, then the slope for PQ3 is 2600 minus 1900, 20 minus 16. If you do that, it's 700 divided by 4, and if you do that, 700 divided by 4, that gives you 175. And let's look at the options we have given here for the problem 3. 175. Okay, for the Q3 it's 1600, 17, 18, 19, and that is 15, 16. So 2600 minus 1900 is 700, and 20 minus 16 is 4. So 700 divided by 4 is 175. But I don't have 175 here, so I'm going to choose which is close to 175, that is 194. Okay, because you, if you can see, it is not actually 1900. It could be more than 1900. That's why my value is slightly different than 194. But it's cool. We just have to choose the the value which is close to this the calculation. Okay, and by doing the very same thing for the Q4, which is actually 18 comma, it looks like in between, so 2200, so that is 2600 minus 2200, 2600 minus 2200 divided by 20 minus 18, which is 2. So by doing that, I can see it's at 200. And that option is, I guess, it's available here. It's a 200. So this is the option for few the PQ for the second the slope of the second line PQ4 is 200. So by looking these options, you can see that the slope of this, as we are going from Q1 to Q2 to Q3 to Q4, these points are going towards P. So that means this slope of these lines, the secant lines, it's going towards 200. That's what it says. So let's go to the next question. It says, which of the following is the appropriate unit for these slopes? As you can see, that slope is distance over time. That means it's the distance is given in meter and time is given in seconds, so it should be meter per second. So this is the answer for this question. And now we have to estimate the object speed at time t equal 20 seconds. So don't forget that speed means it's the rate of change. So when object be at 20 seconds, what is the rate of change? What is the slope of the tangent line? That is what they are asking you. So more you take the point close to P, the slope is going towards 200. So that is the option available here. So approximately Q4 is the closest point to P. So we know that the slope of the line PQ4 is 200. So approximately, this should be the answer. But this is just approximation, okay? And for multiple choice, you can always, pick the approximate value. So that is problem 3. Now let's go to problem 4, which is next page. So problem 4, what is that? Problem 4. And problem 4 is for the graph g of x. This is the graph for the function g of x, and we need to answer this question. The limit of g of x when x approaches to 5. Look at the graph and find when x is approaching to 5. So this is 5. So limit of this function from the left side and from the right side, it's going towards 0. So that's why the limit is 0 here. The left hand limit, and the right hand limit, as x approaches to 5 from left side and right side, both of them are going towards 0. That's why limit is 0. So part B, what is the limit of g of x when x approaches to 9? So let's go to 9 here. This is 9. And as you go from left side, it's going towards 1. But as you go from the right side, it's going towards 2. So that means the left hand limit and right hand limit, they are not equal. Remember, to find out the limit, the left hand limit and right hand limit, they should be equal. So that means for the part B, the answer is the limit does not exist. Okay. For the part C, what is the limit of function g of x when x approaches to 4? So this is what we have to see. From the left side and from the right side, the graph is approaching to 4. So the left hand limit and right hand limit, both of them are approaching to 4. So the limit does exist, and that is 4. Okay, that's problem 4. So let's go to problem 5. Problem 5 is, what is the limit of the function polynomial 3x plus 11 when x approaches to -2? So this is the polynomial. So there is a rule for the polynomial. The limit of the polynomial is the value of the polynomial when x is that exactly -2. So to find that thing, you just have to plug -2 for the x and do the calculation. It's -6 plus 11, which is +5. So that's the limit for problem 5. For problem 6, find the limit. And you can see that on the top part there is a polynomial, on the bottom part there is a polynomial. But as you put x equal 19 for the bottom part, it will be, undefined value. So before you plug x equal 19, you have to simplify this. And to do that, find out the factor on the top, which is x minus 19. And if you try to factor this thing, it would be x squared minus 19 squared. 361 means 19 squared. By using the difference of square formula, we can have x minus 19 and x plus 19. So we can cancel the common factor, and that gives us 1 over x plus 19. And now we can put x equal 19 here and that will give us 1 over 38. That's the limit of this. So remember, for this kind of rational function, before plugging x, before finding the limit, you always have to simplify the rational function if it's undefined. Okay, so that's 1 over 38. Let's go to problem 7. One more time. When x equals to 2, if you put x equal to 2 here on the denominator part, it would be 0. So before plugging x equal to 2 here, we try to simplify it, and there is a one way to simplify it. You can just multiply the numerator and denominator by conjugate value, meaning because I want to get rid of this radical sign, I can multiply the top part and then bottom part by the conjugate of this term, which is square root of x squared plus 21 plus 5 square root of x squared plus 21 plus 5. By doing that, you can see on the top part, you see it's like a minus b times a plus b. So for that, I can write a square minus b square. So that means I can write square of this thing minus square of 5 over, I don't have to, do anything here. Just write this thing as it is and just try to simplify the thing you have on the top part. If you use a square thing on the top part, it would be x squared plus 21 minus 5 squared, which is 25, over this factor here, and that is x minus 2, and then square root of x squared plus 21 plus 5, and keep simplifying the thing. If you keep simplifying on the top part, you will get x squared minus 4, which is actually x squared minus 2 squared. So you can use the difference of the square formula one more time. So you can find the factor on the top as x minus 2 and x plus 2. We already have x minus 2 on the denominator, and there is a square root of x squared plus 21 plus 5. Now we can just cancel out this x minus 2. Now our goal is to find out the limit of this expression. So before plugging x equal to 2, we just simplify this. You have to keep writing limit x of x equals to 2. So our goal is to find limit of this expression x plus 2 over square root of x squared plus 21 plus 5. Remember, this problem and then original problem, they are same. We just simplify this original problem and change it to the this form. So now we can put x equal to 2 on the top, and that gives us 4, and x equal to 2 on the bottom, that gives you 2 squared plus 21, which is the square root of 25, which is 5 plus 5 is 10. So if you simplify this, it will be 2 over 5. So the answer for problem 7, the limit is 2 over 5. Okay. So let's go to the next problem, problem 8. Before we do the next problem, problem 8, we have to make sure that we know the limit of sine x when x approaches to 0. Okay, so if you remember the graph of sine x, look like this. If you just keep going like this. So when x approaches to 0, sine x approaches to 0. So that's the limit. So if we use that expression here, it is actually limit x approaches to 0 3 times sine x minus limit. I'm using the property of the limit, so I can apply this, I can distribute this x approaches to 0 for both of them. Because by using this graph, I can say that the limit of sine x would be 0, so this part would be 0, So the only part is the second part where I don't have any x, it's just a constant. So eventually I'm going to get -1. So the limit of this expression is -1. Okay, -1. Okay, so this is -1. Let's go to the next problem, problem 9. This is epsilon delta problem. Suppose that the interval AB is on the x-axis with the point x0 inside the interval. For the given values of AB and x0, find the values of delta such that uh, absolute value of x minus x0 is less than delta, implies x is in between A and B. So we have given the value of A and B, and we want to make sure that on the x-axis we want to find out the value of delta such that for any value of x, that value should be, you know, in between A and B. So let's try to, you know, look at the, try to just plot the these values on the number line here. Okay, so let's try to plot this. In this problem, we have given this number line, and we have given the value of A, which is 9, value of B, which is 21, and value of x0, which is x0 is 18. And now we want to find out the delta such that if I pick any points from, you know, from here, the difference between that point x and 18 should be always less than, you know, I want to make sure that the difference between them uh, should be always inside here from 9 to 21. And I want to make sure, you know, either you go to the left side or right side, the difference should be always same delta. So if I choose, for example, let's say from x0 to A, the difference is 9. Let's say if I choose the delta is 9, and if I create that boundary here around x0, then 9 from 18 is 27, so which is beyond 21. So I'm not going to I cannot choose something x which is beyond 21. So I want to make sure that you know, I would choose the value of delta such that whatever value, value I will pick to the left and to the right of x0 to that delta amount, all the values should be in between 9 and 21. And that is only possible if you choose delta as the smallest, smaller distance from x0 to A or x0 to B. So the idea is you need to find out the distance between x0 and A, which is, you can see that that's the 9, and distance between the x0 to B, which is, you can see that that's the 3. And you just have to choose the lower one as your value of delta. So in this case, if I choose delta equal 3, and then if I draw, if I create a boundary of delta from x0, so I can go up to 3 points, which is here to the right, and up to 3 points, which is here to the left, which means from 15 to 21 with the open parenthesis. No matter what value I would choose between 15 to 21, using this delta equal 3. Don't forget that the distance from x0 to 21 is 3. That's how we are choosing the delta. No matter wherever I go from 15 to 21, the difference of that point and x0 would be always less than 3, and that point would be always inside from 9 to 21. That's what they are saying. We want to make sure that uh, for that delta, the difference between any points inside this interval, and then x0 would be less than delta, which is 3, and then that point x, whatever I'm picking, that is in between 9 to 21. So to find that value of delta, you just have to find out the difference, the distance between x0 and a, and x0 and b, and you have to choose the smallest one, the smaller one. So in this case, that's 3. That's why the answer for this question is the value of delta is 3. Okay, let's go to problem 10. In this problem, this is also epsilon delta problem. To answer this question number 10, you just have to plug the value of f of x, L, epsilon, and to find out the interval on x-axis around x equal to 0, you need to find out the difference between x minus x0 is less than delta. We don't know what is delta here. Our goal is to use this expression and change that into x minus 8 should be less than some value, and that would help us to find out the interval. So I'm going to just use this expression. This is problem 10. F of x minus L is less than epsilon. Plug the value of f of x, which is 7x plus 3. Plug the value of L, which is 59, minus epsilon is 0.56. Now, to simplify this, so this is 7x minus 56 less than 0.56. Don't forget that we want to change this expression so that we'll be able to find x minus x0. In this case, x0 is 8. So another way of thinking about this absolute value situation is this 7x minus 56 is greater than negative of 0.56, 7x minus 56, and less than 0.56. So this is another way of writing the very same thing. Remember, we want to make this middle term as x minus 8, and that is possible if you factor out 7. So 0.56 minus 7, x minus 8, 0.56. And if we divide all the terms here in this inequality, then it will give us 0.08 less than x minus 8 and 0.08. So to make sure that this f of x minus L is less than epsilon, the value of delta we should take is 0.08. But in this particular problem, we are asked to find out the interval, the largest open interval about x0, on which the inequality this holds. Use the interval notation. So to find out the interval notation, just add 8 here, and it will give you the interval. So that means x you can pick is 8 minus 0.08, which is 7.92 less than 8.008. So if we pick x from 7.92 to 8.08, then this expression holds. So to answer this question, we start from the from the opposite. We start from f of x minus L less than epsilon, and we solve for x, and that gives us the interval 7.92 comma 8.08. That is the largest interval we can take, which we can take for the value of x, which makes sure that this difference between function f of x and L should be always less than epsilon. So for the second part, as you can see that the largest value of delta, as you see, they are actually related. As you can see, this expression can be written as x minus 8 is less than 0.08. So this 0.08 can be taken as the value of delta. So we can answer the part B, which is the value of delta, as 0.08. Okay, so that's problem 10. And now let's go to problem 11. And problem 11 is very kind of similar to problem 10. Here, we want to find out the largest open interval x0 about x0 on which this inequality holds. So we want to, answer the very similar question here. So we are going to do the very same thing. We plug the value of f of x, L, value of epsilon, and finally we try to find the interval. Okay, let's do the very same thing here. This is problem 10 and 11. They are very similar. So for the 11, f of x is the function f of x is given, which is 1 over x. L is given, which is 0.5, is less than epsilon, which is 0.005. Don't forget that we use this expression and we try to find out the range of x, or x minus x0, which is x minus 2. So let's try to do this. This expression, because of this absolute value sign, can be written as a negative 0.005 is less than 1 over x, less than 0.5 is less than 0.005. This is exactly same as problem 10. So now solve for x. Just add 0.5 here, 0.5 here, 0.5 here. By doing that, on the left side we're going to get 0.5 minus 0.005, which is let me do that. 0.5 minus 0.005 is 0.495 is less than 1 over x is less than 0.505. We don't want to find 1 over x, we want to find x. So we can take the reciprocal of this thing, and whenever we take the reciprocal, this sign, the inequality sign, will flip. So take the reciprocal of 0.495, which is let me do that, which is 2.0202, and reciprocal of 0.505 is 1.98. So let me rewrite it. If we take the reciprocal, meaning just flip it, if you flip that 0.495, flipping that gives you 2.0202 is greater than, after flipping you have to reverse the sign as well. X is greater than 0.505, flipping gives us 1.98. Okay, so the value of x should be in between 1.98 to 2.02. If you want to go, more decimal, so that should be this. So you can pick, to have this expression, you can pick x from this interval 1.9802 to 2.0202. So you can use that as a open interval for this first answer. So that is the largest open interval about x0 on which this inequality holds is 1.9802 comma 2.0202. And to find out the value of delta, delta is always the distance, the smaller distance from x0 to one of these boundary points. These are the boundary points. So if you try to find out the difference between 2 and 2.0202 and 1.9802, the delta, you can see it's a 0.0198. If you just find out the difference between them, the smallest one would be 0.0198, right? I can just subtract 2 minus 1.9802 is 0.0198. So that's the closest one. So I can take delta as 0.0198. If I subtract 2 from 2.0202 minus 2, so the distance of these are the boundary points, as you can see here, from where I can pick the x. So you can see I can pick from 1.9802 to 2.0202, and if we have to create a open interval around x0, which is 2, and if we have to create that open interval, and if we have to choose the delta, remember, if you go back to problem 9, the way we choose the delta, we have to do the same thing here. You find the difference between these 2 points and difference between these 2 points, and you choose the smaller one. So the difference between these two one is 0.0198, and difference between these two is it's a 0.0202. So this one is the smaller one. That's why the value of delta is 0.0198. Okay, so that's um, problem 11. And problem 12, we are going to do a very similar kind of problem here as well. Okay, for problem 12, we need to find out the limit of the function f of x. So since the function here we have given is polynomial function, so we can find the limit when x equals to x0. You can see that that's 5. So it's easy to find because the limit of polynomial function is just plug the value of x here. So it will be 5 minus 25, which is negative 20. So the limit of the function L is negative 20. So this value is negative 20. So now to find the delta, we're going to use the same trick we did for problem 10 and 11. So we start with f of x minus L, which is 5 minus 5x minus L is negative 20, and it's less than epsilon, which is 0.04, and we just simplify this. So after simplification, it will be negative 0.04 is less than this expression, which is negative 5x plus 15 is less than 0.04. Okay, so now we can just simplify, and we can just find the value of delta, and it can be found by if we make this middle expression as x minus 5, because x0 is 5, so this middle expression should be x minus 5. So just try to simplify this, and let's do that here. If you try to simplify, if you want to get rid of this 15, you can just subtract 15. So it will give us, I'm going to use space on the right side here. So this is here, which is problem 12. So it gives me negative 15.04 is less than negative 5x is less than negative 15 plus 0.04. So that is 0.04 minus negative 15. It's a negative 14.96. So because there is a negative 5, we can just divide by negative 5. But remember, when you divide by negative number, this inequality sign just reverse. So if I divide negative 15.04 by negative 5, it gives me 3.008 is greater than x is greater than I have to divide 14.96 by again -5, which gives me 2.992. So x should be from 2.992 to 3.008. Is that okay? X should be from 2.992 to 3.008, right? Okay, and after that, okay, in this problem, I slightly, I did a little bit mistake here. So when I add this negative times negative is positive 20 and positive 5, it should be 25. So I should subtract 25, not 15, okay? So when I subtract 25, now this problem becomes negative 25.02, negative 24.96, and if I divide, it will be 5.008. And if I divide 24.96, negative 24.96 by -5, it will be 4.992. So x should be in between 4.992 and then 5.008. Now to find out the delta around x0, which is 5, we need to find out difference between these 2 points and difference between these 2 points, and we need to choose the smaller one. So if you find the difference between 5 and 4.992, which is 0.008, and 5.008 and 5, you will get the same difference, that is 0.008. So that means the value of delta should be 0.008. Okay, so that's problem 12. Let's go to next problem, problem 13. We have some true false question. It's not going to take a long time here. Use this graph and true or false. The limit of the function when x approaches to -3 from right side is 9. So look at -3. -3 is here. From right side means from this side. -3 is here. From right side means this side. The graph is approaching to 10. So here it says 9. Oh yeah, graph is approaching to 9. That's right. So the answer is true. Okay, when x approaches to -3 from right side, the graph is approaching to +9. Here you can see that. That's why the answer is 9. That's true. For the second part, when x approaches to 0 from left, don't forget that we are looking at 0 from left. The graph is approaching to 0, but here it says the graph is approaching to, the limit is 4, left hand limit is 4, so this is false. For the third one, the left hand limit and right hand limit when x approaches to 0, you can see this graph from left side and right side, the value is approaching to 0, so that means they are right. So that's true. Okay, and because left hand limit and right hand limit when x approaches to 0, they are same, they are 0, so the limit exists. That's true. So to make sure that any limit exists, you have to just look at the left hand limit and right hand limit at that point. If they are equal, the limit does exist. Okay, next one, the limit of the function when x approaches to 0 is 0, and that is true because from the left side and right side the limit is 0, and that's why the limit would be 0, so the answer is true. Next one, when x approaches to 3, the limit of the function when x approaches to 3 is 9, so look at the 3 for this graph. You can see the graph here when x approaches to 3, this is 3. From left side, it's the left hand limit is 9, but the right hand limit is 0. So that means the limit does not exist when x approaches to 3. So the limit is not 9, so this is false. So when x equals to 6 from left side, look at here, left side, when x equals to 6, the limit is 6, but that is false because the limit is 0. So this is false. Okay, so we can always use a graph to find out the left hand limit, right hand limit, and the limit of the function. Now let's go to problem 14. We need to find out the following limit when x equals to 0.5 from the negative 0.5 from right side. We need to find out the limit because the limit of the function does exist here from the right side. To find out the limit, you just have to plug the value, and then if you put x equal negative 0.5 here, it's a negative 0.5 plus 2 over negative 0.5 plus 1, which is the square root of 1.5 over 0.5. This will be actually square root of 3. So the limit is the square root of 3. Because there is a polynomial on the top, there is a polynomial on the bottom, you can always find the limit, any limit, either it's a left hand limit or right hand limit, if this function is defined at that point. And we know that this function is defined at negative 0.5, so we can find the limit by substituting the value of x negative 0.5. Okay, so that's problem 14. Now problem 15, we need to find out, we need to use this limit of sine theta over theta when theta tends to 0 is 1, and find out the limit of this expression. So let's say this expression is y equal square root of 7 theta, and by plugging that, now this problem would be, when theta equals to 0, this value y should also equals to 0, and this problem becomes limit y equals to 0 7 sine y by y. I'm just replacing y by square root of 7 theta, and because 7 is a constant, I can keep this constant outside, and that is limit y equals to 0 sine y over y. And according to this, sine theta over theta when theta equals to 0 is always 1, so the limit of this expression is 1, so it's 7 times 1, so that means the final answer is 7. Okay, let's go to problem 16. Identify an interval on which function is continuous. Let's check from 4 to 6. 4 to 6, not including 4 and including 6, but you can see that there is a hole, so this is not continuous. 3 to 4, where 3 is including and 4 is not including, so 3 to 4 not including 4, this is continuous. You can also check 4 to 6, 4 is not should be not including, but here it's including, so this is not continuous, this is not continuous. 4 and 6, 4 and 6 interval also contain this point 5. At 5 the function is not continuous, so this is not continuous. So the only option where the function is continuous is 3 to 4, where 3 is including and 4 is not including. That's problem 16. Let's go to problem 17. Determine the points at which the given function is continuous. You can see that this function, the first part is it's a rational function. There is a denominator, and rational function is continuous wherever this function is defined. But this denominator part, x minus 11, because of that this function is not defined at x equal to 11, because that makes this part 0. So the only place where this function is not continuous is x equal to 11. So if you want to write down this as an interval notation, so this function is continuous from negative infinity to positive 11, and from positive 11 to positive infinity. So this function is continuous everywhere except 11. Let's go to problem 18. We have to find out the limit of this quotient function. We know quotient function is continuous function. So you can always interchange the limit. You can always take this limit inside, or you can see this as, composition of two continuous function. Cosine 6x, this is the continuous function. Cosine of this expression, that is also continuous function. So composition of two continuous function is continuous. So that's why this function is continuous at x equals 7, -7 pi over 12. Actually, this function is continuous, everywhere, anywhere. So to find out the limit, just plug x equals -7 pi over 12. If you do that, this inner part would be 0. And because of that, you get cosine 12 times x, which is -7 pi over 12, which is again cosine pi, and which is your -1. So cosine pi means -1. Remember, when I'm trying to solve this problem, I use cosine function as a continuous function. We know that it's a continuous everywhere, and cosine is even function, and cosine pi is -1. So I use this three fact, and I found this is already yes. The limit, you just have to plug x equal to -7 pi over 12, and this expression will be 0, and that will give you 12 times -7 pi over 12, and if you cancel that, it will give you negative pi. But cosine value at negative pi and positive pi will be -1, so the answer is -1. Let's go to problem 19. Find out g5 for the given function so that this is continuous. If you try to simplify this, it will be 4 times x minus 5 and x plus 5, because if you factor out 4, it will give you x squared minus 25, and then on the denominator part, it is 4 times x minus 5. This function is you know undefined when x is equal to 5. So to make this function continuous at x equal to 5, we cancel x minus 5, 4 and 4, and now this function becomes x plus 5. So to make this g of x continuous at 5, we have to define this function. The value of g of 5 should be, the value of g of 5 should be, just use this expression, 5 plus 5, which is 10. So if the value of g of 5 is 10, then this function would be continuous. We can make it continuous. So you have to simplify the expression, and you have to put x equal to 5 here, and that will give you the value of the function which makes this function continuous. Let's go to problem 20. Use this graph to answer this question. When function f of x when x equals to 4, select the correct choice below and fill in the answer box within the choice. So the limit of the function when x equals to 4. So look at the 4 here, and the limit of the function when x equals to 4, you can see that it's -3. This is -3. So this is the right answer. When x equals to -3 from right side, -3 is here. From the right side means this side. This graph is approaching to -4. So so the graph you can see here, when x approaches to -3 from right side, the graph is approaching to -4. So this is the answer for B. For C, when x approaches to -3 from left side, from left side, you can see that it's going to 2. So this is 2. Because left hand limit and right hand limit, they are not equal. So the the limit of the function when x approaches to -3 does not exist. So this is the right option. And for E, when the limit of the function when x approaches to 2 from right side, 2 from right side, from this side, it's a right side limit is -3. Okay. And when x approaches to 2 from left side, as you can see that left side means this side, when x approaches to 2, it's keep going. There is no stop sign. So it's you can say infinity, or you can say limit does not exist. It's infinity, it's going up and up and up. To answer this question, when x approaches to 2 from so you can see that the right hand limit and left hand limit, they are not equal. So limit of the function when x approaches to 2 does not exist. And the limit of the function when x approaches to infinity, as you can see, as x in approaches to infinity. Look at the graph one more time. Here is the graph. X approaches to infinity. So this graph, when x approaches to infinity, when x is infinity, this graph is approaching to, as you can see here, it's approaching to -1. So we can say this is -1. -1. You see this line here, -1. So that's why we can say it's a -1. When x approaches to infinity, the limit of the function is -1. Let's go to next place, -1. And when x approaches to negative infinity, you can check, the here, negative infinity, this graph is approaching to -2 as well. If you are going to this side, this graph is approaching to -2. So this would be -2. Okay, that's problem 20. Let's go to problem 21. Find out the limit when x approaches to infinity. This would be 2x plus, so the function is 2x, the function is 2x plus 2 divided by 4x plus 8 when x approaches to infinity. To find out the limit of this kind of function, you can just first simplify whenever it's possible. X plus 1 and 4x plus 2. When x approaches to infinity, what you can do is you can just factor out x one more time here. So it will be 1 plus 1 over x. It will be 1 plus 2 over x. This x and this x cancel out. When x approaches to infinity, this second part would be 0. This second part on the denominator would be 0. So when limit x approaches to infinity, this expression here, this part would be 0, this part would be 0. So it will be just 1 over 1. It will be 1. Okay. Okay, I missed 2 here because there is a 2. So it should be 1 over 2. So the answer is 1 over 2. When x approaches to positive infinity, it's 1 over 2. When x approaches to even negative infinity, the second part and then the numerator part and denominator part, again it goes to 0, and once again this is again half. So this part, either it's positive infinity or negative infinity, this part would be always 0, and then only leftover term would be the constant 1 over 2. So that's why it's a 1 over 2. For problem 22, find out the limit when x approaches to infinity. We are going to use the same trick here. We're going to simplify first. For that, it's a cube root. So we just factor out x to the power 5, 3 over x to the power 5 plus 8 divided by x to the power 5, 1 plus 3 over x to the power 5. It's a cube root. So when we try to find out the limit when x approaches to infinity, we can see that this part would go to 0, this part would go to 0, and finally we get a square root of 8, which is actually 2. So the limit is 2. For this graph, for this problem 23, we are going to use this graph, which is graph of 1 over x. When x approaches to 0 from left side, you can see that the graph is going up and up and up. So we can say from left side, when x approaches to 0, from left side the graph is going down and down and down, so that means it's a negative infinity. Problem 24. You have to, before finding this limit, you have to simplify it. So to simplify it, you have to multiply by the conjugates, and then after that you can find the limit. Conjugate means same thing but different sign. You can multiply by that on the numerator and on the denominator. So I'm going to do that. I'm going to multiply square root of x squared plus 36 minus square root of x squared minus 1 on the top part, and on the bottom part minus. So that's the simplification. By doing that, what happens is the top part, it will be more simplified version. Now I have to multiply by conjugate, so there should be plus sign. On the top part, it's a square of this minus square of this, because you can see that it's a minus b times a plus b. So square of this square root gives you x squared plus 36 minus x squared minus 1, and on the bottom part this is just square root of x squared plus 36 plus square root of x squared minus 1. And now if you simplify the top part, this x squared and this x squared will be cancelled out, and on the top part you will have 36 plus 1, which is 37, and on the bottom part we can always factor out x squared. No matter you factor out x squared or not, this you will not be able to cancel out x from the bottom part. So whenever x approaches to infinity, because there is x on the bottom part, this whole part approaches to 0, because there is x, and there is no way you can find out the x on the top and cancel out with this x. So when x approaches to infinity, because of this x on the denominator, this part goes to 0. So the answer for this limit is 0. Okay. And finally, the last problem for this review, that's problem 25, and some of the answers are already selected. Let's see either they are right or wrong. Find the horizontal, vertical, and oblique asymptotes. So the first question is find the horizontal asymptote. To find out the horizontal asymptote, we compare the degree on the top and degree on the bottom. If the degree on the top is greater than degree on the bottom, there is no horizontal asymptote. So that's why the answer is B. For the vertical asymptote, you always equate the denominator with 0 and solve for x. So x equal to 6 is your vertical asymptote. And for the oblique asymptote, that's possible if you have the degree on the numerator is 1 greater than the degree on the denominator. As you can see that the degree on the top is 2 and the degree on the bottom is 1. So the oblique asymptote is possible. This is not right. Oblique asymptote is possible, and you can always find that by dividing 11x squared by x minus 6. So 11x gives me 11x squared minus 66x. I change the sign, so it's a 66x. So now plus 66x minus 39. So now there is just a constant left over. So the oblique asymptote, to find the oblique asymptote, if the degree on the top is 1 greater than the degree on the bottom, you can always find by dividing the the numerator by denominator and finding this this quotient. Y equal this quotient is your oblique asymptote. So y equal 11x plus 66 is your oblique asymptote. And then if you try to plot all these information here, you can choose the right graph. You can see that the graph must have x equal to 6 as a vertical asymptote. So look at here, the graph must have x equal to 6. 1 2 3, so and then y equal to 11x plus 66 is the right graph. So x equal to 6, 1 2 3. So which one is the right one? And you can also find out some of the points, like when x is 0, the y is 0. So you can see that there are two graphs where x is 0 gives you the y is 0. So these two, right? So this is not right. Oh, this is also 0 here. So it might be true, this might be true, this might be true, this might be true. But now we're going to use the vertical asymptote. The vertical asymptote is x equal to 6. So pick the x equal to 6 here. This is not x equal to 6. This is this. It looks like x equal to 6, but we need the the oblique asymptote 11x plus 66, and you don't see the oblique asymptote 11x plus 66 here, so this is not right. And here this is also not right because this line is not y equal 11x plus 66. So this is the only possibility we have. So this is the answer. Because of this x equal to 6 vertical line and y equal 11x plus 66 line, this is our right choice. Okay, so it was review, exam 1 review. If you still have some questions, then feel free to email me. Okay.